Imagine a world gripped by catastrophic planetary tides, flooding our great cities, plunging us into pitch-black nights, and ushering in an ice age more powerful than any in Earth's history, all under evening skies shaded with tungsten. This is the reality we would face if we traded our moon for other moons within our solar system. And a spoiler, surviving most of these swaps would be impossible. Let's begin this epic journey with a truly titanic moon, Titan. You are accustomed to our familiar, regular moon. You know its size, the appearance of its surface, covered in a gray lunar regolith. What you are accustomed to seeing in the sky is a familiar sight, but this is not that. This is Titan, a moon orbiting Saturn, but one of colossal scale. It holds the distinction of being the second largest moon in our entire solar system. It is so substantial, in fact, that it is even larger than the planet Mercury. Yet unlike Mercury, Titan exists in a state of deep freeze. The temperature here plummets to a bitter -180 degrees Celsius, which is a staggering -290 degrees Fahrenheit. Its landscape is eerily familiar, carved with rivers, lakes, and vast seas, much like those found on Earth. There is, however, a profound difference. These expansive bodies of liquid are not composed of water. They are made of methane, and it is a place you would most certainly not want to take a swim. If we were to replace our familiar moon with Saturn's Titan, the transformation in our night sky would be both subtle and profound. Gone would be the silvery white light we know so well, replaced instead by a deep golden-orange twilight that would wash over the world. This new, titanic moon would command a larger presence overhead, its diameter about 1.5 times greater than that of our original satellite. But Titan is no ordinary moon. It possesses a remarkably thick, nitrogen-rich atmosphere that extends nearly 600 kilometers into the void of space. As a result, our new lunar companion would not appear as a sharp, defined disk, but rather as a colossal, fuzzy orb of orange light. So far, this might not seem like a monumental shift, unless, of course, you have a particular aversion to the color orange, or find it challenging to find words that rhyme with it. But the situation is about to become truly dire for our planet. Titan is a colossal world, a full 80% more massive than our own moon. This greater mass means its gravitational pull on Earth's oceans would be significantly more powerful. The consequences here on Earth would be profound. The rhythm of the tides would be violently exaggerated. High tides would surge to unimaginable heights, while the low tides would retreat to startlingly low levels. While we could manage the lower tides, it is the immense daily floods that would be catastrophic. Our coastal cities would be inundated, not by a rare storm, but by this relentless cycle twice each day. Every shoreline would experience intensified erosion and turbulent, churning waters. This would be the one moment you'd be grateful not to own that coveted beachfront property, for by now, those lands and the homes upon them would have been swallowed by the sea. The story would be no different for Titan. Having journeyed all the way from Saturn's orbit to our own, this moon would be bathed in vastly more solar energy from the sun. It would begin to warm. For all the methane gracing its surface, it would be the beginning of the end. Titan's vast methane lakes would eventually evaporate into the growing warmth. Its icy crust would begin to melt away, and soon it would unveil the watery, subsurface ocean hidden deep below. And that moment could be a truly profound one. If any life exists in that hidden ocean beneath the icy shell, we would finally be able to land on Titan's surface and seek it out. Now, this vast ocean could be hundreds of kilometers deep, which suggests there is so much more territory to explore and potentially so much more to discover. The unfortunate reality, however, is Titan's low gravity. This means it could not hold onto all of that liquid and its thick atmosphere indefinitely. Over millions of years, it would slowly bleed its gases and water out into the void of space, gradually drying out. Ultimately, this moon would transform into a world as barren and lifeless as our own familiar moon. Farewell to that hazy, methane-rich orb in the sky. Titan is not the only entity that exists in a state of profound cold and stillness. A similar fate could await your own future if you fail to remain relevant within the constantly shifting landscape of the professional world. To address this, a comprehensive AI mastermind workshop has been designed, condensing years of advanced knowledge into an intensive 2-day program. This exclusive event spans 16 hours, packed with critical content covering AI tools, advanced prompt engineering, process automation, and the methodology for building functional AI products, all without requiring any prior coding experience. The workshop is scheduled for this very weekend, running on Saturday and Sunday from 10 a.m. to 7 p.m. Eastern Time. Past participants, many of whom began with no prior expertise, have successfully built and launched over 100 AI products, complete with revenue models that have generated upwards of $5,000 per week. Of course, that information seems like it must be highly proprietary. One would assume such a program carries a significant cost, and normally you would be correct. The standard price is set at $900. However, a special arrangement has been made to provide 1,000 complimentary seats at absolutely no charge. This opportunity is offered solely to this audience and will remain available only for the next 72 hours. With a stellar rating of 4.9 out of 5 on Trustpilot and an included pass to an exclusive AI mastermind workshop, these available spots are expected to be claimed very quickly. The endorsement of 10 million participants in the last year alone speaks to its value, and now the chance is yours. This workshop presents a significant opportunity to acquire valuable skills that can place you at the forefront of this field. And with timely enrollment, you will also receive 3 additional resources: a comprehensive prompt library containing over 3,000 entries, a detailed guide for monetizing artificial intelligence, and a customized tool for building your own AI toolkit. All of this is available without any cost. To secure your place, simply use the registration link provided. This session is a considerable chance to advance your knowledge, and speaking of things on a grand scale, let us return our gaze to the moons and explore what other upheavals our planet could potentially face. Now, if Titan seemed impressive in scale, then this next moon is truly gargantuan. The only moon in the entire solar system that surpasses Titan in size is Jupiter's Ganymede. It also holds the unique distinction of being the only moon known to possess its own magnetic field. With a diameter roughly 1.5 times that of our own moon, it would appear about the same size in a night sky as Titan would. But instead of casting an orange-tinged glow, Ganymede would shine with a startling brilliance. This is because its surface is covered in ice, and that frozen landscape reflects sunlight far more effectively than our own moon ever could. From your perspective here on Earth, this new celestial body would now appear vastly brighter in the night sky. This would pose a significant problem for astronomers, as the overwhelming glare would severely limit their view into the depths of space. You might even find yourself needing heavier curtains to block out the intensified light at night. While that may not seem catastrophic just yet, the most dramatic consequences are still to come. Remember, Ganymede possesses nearly twice the mass of our original moon, and its far stronger gravitational pull would unleash a global era of megatides. Imagine a world where, like Titan, our coastlines would flood twice daily, battered by relentless waves and wild erosion, all under the threat of immensely destructive storms. The presence of Ganymede would be earth-shaking in the most literal sense. Its immense gravitational pull would strain our planet's very crust, triggering earthquakes and sparking volcanic eruptions on a global scale. Yet, for any who might survive to witness it, there would be one profound benefit. Ganymede would actually stabilize the Earth. More precisely, it would steady our planet's axial tilt. This single change would bring an end to ice ages, locking our world into a steady, permanent climate. And as for Ganymede itself, it would begin to warm. You might assume the moon is a cold place, but when bathed in direct sunlight, its surface can become searingly hot, reaching a staggering 125 degrees Celsius. That's 260 degrees Fahrenheit. So yes, our moon can become an oven. Yet Jupiter and its moon Ganymede receive only about 1/30 of the sunlight that the moon does. As a result, Ganymede remains profoundly cold, with temperatures on its warmest days hovering around a frigid -112 degrees Celsius. This world has been locked in a deep freeze for billions of years. Now, as Ganymede experiences internal heating, its immense crust of ice, a shell 150 kilometers thick, would begin to change, starting to sublimate directly into vapor or perhaps even melt. This frozen world would no longer be locked in ice. It would now be adorned with vast oceans and weather systems of water clouds. Beneath that newly formed surface lies an immense, global sea of salt water. To truly comprehend it, imagine an ocean 100 kilometers or 60 miles deep. In time, you might find yourself vacationing on Ganymede rather than a tropical resort on Earth. Ganymede possesses its own magnetic field, and with it, the spectacular phenomenon of auroras. Picture journeying to a far northern latitude to witness our own northern lights, and there, painted across the sky, you would also see the shimmering auroras of Ganymede. It's a breathtaking thought. While Ganymede might have obliterated everything familiar on our world, it would, in its own right, become a remarkably inviting place. If you have managed to survive all these earthly disasters, you could consider making a home there. Now we journey to a true hellscape of a moon, Io. As the third largest moon of Jupiter, Io is infamous for its hundreds of volcanoes, which violently blast molten sulfur lava hundreds of kilometers out into the void of space. This makes Io the single most volcanically active body in our entire solar system. The reason for this relentless fury is the phenomenal gravitational push and pull it endures, caught in a celestial tug-of-war between the massive planet Jupiter and its own hefty neighboring moons, Europa and Ganymede. These immense tidal forces cause extreme physical distortion of the moon itself, generating intense internal heat. It is this very heat that ultimately unleashes itself through the moon's endless, spectacular volcanic activity. The surface of this virtual inferno is covered in volcanoes and seething lakes of molten lava. It would create a truly phenomenal spectacle the instant we replaced our own, comparably static moon. Our moon's volcanoes have been silent for millions of years, but Io would be spectacular to watch from Earth. By night, it would shine with a golden-orange glow, 5 times brighter than our familiar moon. With just a simple telescope, you would be able to witness Io's volcanoes actively erupting. Yet, for as hellish as Io might sound, it wouldn't be such a bad companion for Earth. Consider, for a moment, that Io is remarkably similar to our own moon in both its size and its mass. You would likely witness a modest rise in tidal activity here on Earth, but certainly nothing catastrophic. However, without the immense gravitational forces of Jupiter, and without its neighboring moons Europa and Ganymede locked in a constant celestial tug-of-war with it, this new moon would be released from the relentless three-way stress that has tormented it for eons. That very stress is what heated its interior to an extreme, fueling the vast network of volcanoes that scar its surface. Freed from this torment, Io would gradually cool. Its spectacular volcanic eruptions would cease, falling dormant, and our new moon would, in time, become a cold and silent world, not so different from the one that currently occupies our night sky. So, what would occur if we were to exchange our familiar moon with one of Jupiter's most celebrated satellites? Let us now consider Europa. This is a moon that has captivated our imagination for decades. Ever since the Voyager and later the Galileo spacecraft returned their first close-up observations of the Jupiter system in 1979, scientists have been profoundly intrigued. Their focus has been drawn to Europa's smooth, icy exterior and the compelling theory of a vast, global ocean hidden beneath its frozen shell. This, of course, immediately raises the tantalizing possibility of life existing in those dark, subsurface waters. Yet Europa held even more surprises in store. During the 1990s, as NASA's Galileo spacecraft was meticulously mapping Jupiter's powerful magnetic field, its instruments registered something truly anomalous. Right at the orbital position of Europa, the magnetic field appeared strangely warped. Europa itself possesses no magnetic field, so what was the source of this disturbance? The answer, scientists believe, lies hidden beneath its frozen crust. Europa is thought to harbor a vast, subsurface ocean of salty water. As Jupiter's immense magnetic field sweeps past the moon, it agitates the electrical currents within that hidden sea. These swirling currents generate a temporary secondary magnetic field, the very phenomenon that the Galileo spacecraft detected. This global ocean on Europa could be as deep as 150 kilometers, or 100 miles. It's a significant amount for a moon. To put that into perspective, the deepest point in any of Earth's oceans measures just 11 kilometers, or about 6.8 miles. So if we were to exchange our moon for Europa, the effects on Earth would be substantial. For one thing, Europa's bright, icy surface would reflect more than 5 times the amount of sunlight that our current moon does. Furthermore, with its lower mass, the ocean tides we experience would become noticeably weaker. And over the course of millions of years, Europa's gravitational influence would introduce a greater instability to Earth's axial tilt, ultimately triggering some enormous climate swings across our planet. But before Europa could exert its disruptive influence on our planet, you would be granted a far clearer view of it. Now imagine you wouldn't need to dispatch a spacecraft on a monumental journey of nearly 3 billion kilometers, or 1.8 billion miles, just to examine this distant moon. Positioned a mere 385,000 kilometers, or 238,855 miles, from Earth, a trip to Europa would be a matter of just 3 days. With NASA's current plans to return human boots to the lunar surface, by 2027, the prospect of having people walking upon the icy plains of Europa could become a reality in just a few short years. Remaining at the surface, searching for signs of life, is a profoundly compelling mission. In time, however, the story of Europa would inevitably change. Its vast subsurface ocean would slowly begin to freeze solid. The planet Jupiter, the gravitational force responsible for the tidal squeezing that has kept this world warm for billions of years, would no longer be there to exert that same influence. As a result, the moon's surface would paradoxically begin to warm, its icy shell melting or sublimating away into the void. Over eons, Europa would undergo a complete transformation, from a mysterious, sloshing ocean world to a silent, frozen moon. In the meantime, perhaps our explorations would have yielded the ultimate discovery, that we are not alone in the cosmos. Now we turn our attention to another frozen moon, one that defiantly refuses to follow the usual rules: Triton. Triton is a truly peculiar moon. It is Neptune's largest, and it holds a unique distinction in our entire solar system. It is the only moon of its size that orbits in the opposite direction of its planet's spin. Astronomers refer to this as a retrograde orbit. So if we were to swap our moon for Triton and reverse its direction, our new moon would be traveling the wrong way. Much like other moons we've encountered, Triton is a highly reflective, icy world that would glow brilliantly in our sky. However, it lacks the sheer mass of our original moon, and as a result, Earth's ocean tides would diminish dramatically. However, the moon would no longer be the primary force behind our twice-daily tides. That role would be taken by the sun. Yet the sun exerts only about half of the tidal force of our moon. Over millions of years, without the moon's strong gravitational anchor, the Earth's axial tilt would wander much more, leading to unpredictable climate shifts and more extreme ice ages. But when it first appears, Triton would put on a spectacular show, brilliant, moving backwards in its orbit and sporting icy volcanoes. That's correct. Beyond Earth and Io, Triton stands as one of the most volcanically active locations in our entire solar system. Except this is not a fountain of molten rock. It is venting cryomagma from cryovolcanoes, which is truly just an elaborate term for the fact that it is erupting ice, launching plumes up to 8 kilometers, or 5 miles, high into its thin atmosphere. Every single night, we would have a front row seat to witness our moon blasting this cryomagma out into the void of space. Out here in the orbit of Neptune, the cold is so profound that the ice covering this distant moon is not merely water, but a mixture of frozen nitrogen, water, and methane. The surface of Triton stands as one of the coldest known places in our entire solar system, reaching a truly frigid -235 degrees Celsius, which is minus 391 degrees Fahrenheit. Now positioned so much closer to the sun, its surface would rapidly begin to heat up. All of that frozen nitrogen would vaporize, potentially generating a thick, hazy atmosphere and perhaps even a long, comet-like tail. Over the ensuing centuries, Triton would slowly lose its entire icy shell. And if a subsurface ocean exists, that too would begin to dissipate, eventually leaving behind a smaller, drier remnant of its former, brilliantly shining self. Yet in its early days, this transformed Triton would brilliantly illuminate the night sky, creating a spectacular celestial display, a performance quite unlike that of our next moons, Phobos and Deimos. Our journey so far has primarily involved replacing our own moon with either a massive or moderately sized satellite. Now we turn our attention to our neighboring world, Mars, which presents a very different arrangement. The red planet is accompanied by a pair of moons so small they defy the conventional image of a satellite. Phobos and Deimos are officially classified as moons, yet their origin story suggests they may simply be asteroids, captured long ago by the gravitational pull of Mars and now locked in orbit around it. Phobos, the larger of the two, is a mere 27 kilometers, or 17 miles, across at its very widest point. Deimos is even more diminutive, measuring just 15 kilometers, or 9 miles at its broadest. I specify at its widest point, because these bodies are so irregularly shaped that assigning a standard diameter is practically impossible. These moons are profoundly irregular in shape. Each is also more than 100 times smaller than our own moon, and their surfaces are a landscape of craters, charcoal-dark material, immense dust, and scattered boulders. So if we were to swap our familiar moon for the pocket-sized forms of Phobos and Deimos, imagine them painted black, there would be scarcely anything left in the night sky. Our new moons would essentially appear as nothing more than faint, bright stars, or perhaps satellites swiftly moving across the darkness. You would struggle to distinguish them from the surrounding constellations, and the night itself would be plunged into near-total blackness. The familiar glow of moonlight would vanish from our nights, a loss that would create chaos for nocturnal creatures all across the planet. For astronomers, this new dark sky would be a boon, but for the rest of the world, replacing our moon with the tiny duo of Phobos and Deimos would spell absolute disaster. With their insignificant mass in comparison, the ocean's tides would be governed almost entirely by the sun. As the oceanic tides diminish to a fraction of their former strength, marine life would be so profoundly impacted that we could witness the complete collapse of our coastal ecosystems. This, in turn, would fundamentally alter our planet's winds, its waves, and its entire system of global heat regulation. Then, over millions of years, a far more dire situation would unfold. The Earth would begin to wobble wildly. Just imagine trying to say that phrase 10 times in a row. This planetary wobble would lead to completely unpredictable seasons, triggering new ice ages and severe, prolonged droughts. Picture a scenario where the North Pole gradually migrates all the way to the equator, remaining there for 50,000 years. Even more dramatic, and this is truly staggering to consider, such instability could ultimately lead to the end of life on Earth as we know it, or at the very least, an extinction-level event. This stands in stark contrast to a moon like Phobos, which is slowly falling into Mars, moving about 2 meters closer to the red planet with each passing century. In approximately 50 million years, one of two fates awaits this moon. It will either fracture and shatter, creating a faint, Saturn-like ring system around the red planet, or it will be pulled into a direct, catastrophic collision with the surface. So if we imagine Phobos as our own new moon, the view from Earth would be that of a 27-kilometer-wide lunar asteroid plowing into our world in what would appear as agonizingly slow motion. An object of that scale could be twice the size of the asteroid believed to have wiped out the dinosaurs. The result, quite simply, would be an extinction-level event. It's safe to say our current moon is a far more preferable companion. Now we arrive at the final moon on our exchange list, Enceladus. This world is a frozen sphere of ice, orbiting within Saturn's distant rings. Yet there is a powerful force at work beneath its serene surface. Enceladus is not merely a passive passenger. It is an active participant, contributing to the very formation of Saturn's outer E-ring. Indeed, Enceladus is constantly spraying plumes of icy water particles and gas out into the void of space. So what would this mean for us? Once we swap our moon for Saturn's, Enceladus would hang in our sky, perpetually covered in a fresh coat of ice particles and snow. This would make it the whitest and most reflective surface in our entire solar system. So even though it is relatively small compared to our own moon, Enceladus would still shine brilliantly in our night sky. The evenings would certainly be dimmer, yet nowhere near as dark as they would be under the miniature moons of Mars. The fundamental problem with a moon like Enceladus, as with any smaller moon we might substitute, lies in its mass, which is simply too slight to generate the powerful tidal forces that originally helped to shape our world. In the end, losing our moon and replacing it with Enceladus would essentially recreate the same disaster scenario we witnessed with Phobos and Deimos. Such dramatic drops in oceanic tides, coastal catastrophes, and wildly uncertain climate would eventually lead to an unstable planet tilting. Yet at least you would still be able to see a night sky, though it wouldn't take long before all that ice began to sublimate and perhaps melt. Enceladus' ice shell is not nearly as thick as those of some larger moons, like Europa. Very soon, you could witness oceans of water forming on our new moon. And if that means we get another chance to see if life exists anywhere else in our solar system, well, that is a truly compelling prospect. In essence, the idea of trading our moon for another is a fascinating one. However, if the replacement moon were either too large or too small, the consequences would be catastrophic, causing devastation to our fragile coastlines and much of the planet. So, while the chance to witness the volcanic activity on the moons of Neptune and Jupiter is incredibly tempting, I believe I'll remain content with our own familiar moon. When it comes down to it, this is the one place in our entire solar system where you can reliably execute a perfect orbital delivery. But that is a tale that will have to wait for another time.